Hey everyone, Dave from Corso here, drinking my coffee for Bill. Even if it's still 95 degrees out, we still have to drink our coffee. So today we're in for a treat. We're going to talk with John about SPC, which is Statistical Process Control. I like to tell everyone that John is the best person in the entire world with SPC on ignition. And since no one other than John tries to correct me, I'm going to say I'm right. And so we're going to go over what a basics package of SPC on ignition could look like. If you're interested in looking at SPC not on an ignition platform, we'd be happy to talk to you about this. This is specifically on ignition on the demo server that we've built. And we're super excited to talk about it and to show you guys. It took some arm twisting to get John on there. And so without further ado, let's talk to John.
How's it going, John?
Pretty good. How about yourself, Dave?
I'm doing well. Thank you for letting us twist your arm and get you on the video to talk about SPC. Before we jump in, everyone is wondering, are you drinking coffee or have you switched to Red Bull?
I am drinking coffee, and after this cup of coffee is over, I will be switching to Red Bull.
2 coffee drinkers currently in here listening to you talk about SPC.
All right. SPC is short for Statistical Process Control, and it is a method for monitoring, controlling, and ultimately improving a manufacturing process through statistical analysis. The kind of general philosophy around SPC is that all manufacturing processes exhibit some form of intrinsic variation. Ultimately, bad situations, what we end up with is processes that exhibit excessive variation, and that produces undesirable results, aka excessive scrap and increased process costs. And nobody wants that. So SPC is what we use to monitor a process and verify that all of our values are within target. So there are 2 different main buckets of tests that we do within SPC. We do dimensional tests and we do visual tests. That's probably a good place to start with actually showing you guys the SPC application that I've developed and that we've seen use and be successful. This is like the SPC data entry screen. This is what an operator uses on the production floor, and this is where they're going to enter in all their tests, and they can see a little bit of analysis here, but this is mostly for data entry. Let's go to add sample, and from add sample, based on the location we've specified, we're going to see all of the available tests for that location. Location can vary in scope based on your processes and how you want your SPC set up. Ultimately, a lot of times we see locations based off of production lines. In this case, for our demo server, we have just a net weight lab, so it's just a very generalized location. So within here, we have 2 different sample definitions available. We have net weight and we have a non-conformity test. I have a sample test for each kind of test type. We have a dimensional test for net weight and a visual test for non-conformity. So let's hop into net weight. We'll double click on that. So that's going to open up a net weight test. We have sample size of 5 for net weight for each sample. And we can see that the equipment is set to caliper, and we can do data importing straight through a caliper. So we don't have to use a caliper and then manually type in on a keyboard. Everything can be done straight through a caliper and a foot pedal or a button on the caliper itself. We essentially just enter in our values right here. I don't have a caliper set up, so I'm just going to use my keyboard for now. So while I'm setting this weight value right here, we can see the lower spec limit and upper spec limit here. So we have 1 and 8. We have the work order, and the way that I have designed this for this demonstration is that the net weight lab is actually just pulling from line 1 just to show that we can basically, based on a location, we can pull in automatically work orders that are generated. It's going to auto-populate the currently running or most current run for that line associated with the location. And then we can optionally opt to choose. So if we were doing some kind of rework and retesting, we could go back in and associate it with the correct work order. And then we have test type. This is just metadata for a test. So if we want to store all of the startup tests. So that initial test, once production line starts up or a mold starts running, any of those kind of options, we can specify what kind of test this is. So we have startup, adjustment, normal, a deviated test, and some kind of like engineering special request. And we can add to this list infinitum. Say you have a couple operators on the floor that are allowed to adjust spec limits. Maybe there's a deviation. Maybe the spec limit was incorrect for some reason. We can adjust on the fly in the middle of the test. We can adjust these spec limits here. The offset has to do with calipers, where maybe you're taking an inside diameter and you have to measure the offset of the calipers themselves. Maybe it's half an inch, anything along those lines. So we can specify that offset here, and that would add or subtract accordingly to the value that's populated from the caliper. And then comport is for actually connecting a caliper via USB serial. If we go and start entering in some results, so what we're going to see, I click on there, so we go 2. So immediately we can see a little status icon, it's yellow. So the value of 2 turns yellow because we are underneath the lower control limit of 4. Whereas if we were to go to 4, 4 is good, it's within our control limits. Let's do 5 and 8. 8 goes above the upper control limit of 7. And then let's do one out of spec real quick. So our upper spec is 8, so let's do 9. 9 would populate as red. So we can get a nice immediate status of whether these are in spec or in control or not. Before I hit submit, what we see once we actually start the test is we get a current sample. So we get the definition name that we're working on. We get the product code that's associated to the work order. And then, of course, we get the work order name as well. And what we get on here, as far as some kind of simple analysis, is we get the last 25 data points for this sample, regardless of time. This is just to kind of give the operator an idea of how these parts are trending. So obviously, we don't have any kind of pattern as far as trend just through my testing, but this could give the operator some kind of insight to see if there's an upward trend or a downward trend, and just kind of see how much variation is in the process and see if it's trending towards going out of spec. Then ultimately we could alert off of that, or the operator could tell somebody, maybe tell an engineer, hey, these are definitely trending upwards. They're still good, but they are potentially going to be bad shortly. That's kind of what this control chart, this X-bar chart is here for, is to show just the last 25 data points. And same as the process performance. We want to see where they're stacking up according to the bell curve. Deviations, well, it does say none. If there are any deviations assigned to this kind of product code, we would see those here. So if maybe for the next 6 months that lower spec limit was increased to 2, we could see that deviation here, and those can all be set up. So let me go ahead and submit this test. So we're going to get a pop-up because we have a couple samples here that are out of control or out of spec, and we're just going to get a nice notification saying that this sample was flagged for the lower control limit. That lower control limit value is 4, and we measured it as being 2. This is just for operators to verify that there were no misclicks during the input of the sample data. And what we do here is we give them the option to either remeasure, add a note, or save anyways. So if I wanted to remeasure, it's just going to close the pop-up. Then I can come back in here, maybe change that because I didn't actually mean to write a 2. Maybe I meant to write a 4, and then I would submit again, and then I can see that alert goes away, but I still have the other ones, and I'm just going to save anyways. So we see saving sample, everything updates, and now we have that last test that was taken by me at 1:54 p.m. today. We can see that it was taken on first shift at this location. Tag is for declaring ownership of each test. It's not being used in this demonstration, and that could ultimately be used for whatever you want it to be. And then if there was a note associated with it, we can associate it here. Say there was an issue with the way it was imported. maybe one of those test values needed to be adjusted, we could always edit the sample again. Right click, edit, we can alter those values accordingly. We can add a note here, say this is a note. Save that, and then we are good to go. There goes our note once it refreshes. This is a note. Basically, in essence, how a dimensional test works within the SPC application. The other one is the visual test. So let's go over to a nonconformity test. We'll double click on that. We can see that our charts change based off of the test type. So now we get a U chart, which is just a percentage failed chart. And then we get a Pareto as well as a summary. So summary is just going to tell you how many parts have been inspected. So we have 40 parts inspected, 23 of them actually failed. That gives us a quality percentage of 42.5. So in here, once we're actually taking the test, everything else on the page is going to be the same as a dimensional test, except for the way that you're actually entering in values. So as you can see, we already have all of these values already inputted for us. That's because most of the time, we're going to be inspecting the same amount of parts, and ultimately and hopefully you're going to have 0 visual defects on them. So we can assign a default value to these, and if there's a default value assigned, then I'm just going to automatically populate it in the application so that when everything is good and the inspection count stays the same, you can open the test, everything's populated, you can save the test. Don't have to do anything else along those lines. If there was a case where maybe there's just one contamination, or let's say 2 contaminations, we can just override that 0 to a 2, and then we can submit it on. So it's super quick and super easy for an operator to enter in these visual tests. And then everything is populated in here for the samples completed. Right now, this is set up to only be the samples completed for a specified shift. Ultimately, that can change based on needs. That's just a way to keep this list from growing abnormally. Let's move over to the analytics side. So now we have some data captured. Now we want to start analyzing it. So we can go over to this analytics page. What we can do here is we can select a location. So we just took some tests at the net weight lab, so let's select that one. And then from here, we can select a sample definition that we can start looking at. So we did the net weight first. Let's go check that one out. So as soon as I click that, we're going to see all of the available attributes within that test that we can filter by. So there's only weight on this one. It's automatically going to populate us on the summary page. And this is just a very high-level summary of how many tests were taken. So we've taken 19 samples in this time range specified, so current week. The upper spec limit's 8, lower spec limit's 1, the tolerance is 7, our target value or our nominal is 4.5, our X-bar value is 5.68, our standard deviation is 1.95, the minimum value entered within those 19 samples was 2, the maximum was 10. Our PP calculation was 0.6, and our PPK was 0.4. So if we move down to a control chart, now we can see a much bigger and more filterable, more robust control chart to use for analysis. So, ultimately we can select just this time range, or we could, technically go into custom and maybe let's grab the last year or so, and then we can see a lot more data that's populated. We have a couple chart options. We can either choose to show this table on the top or hide it to get a bigger chart. We can choose to show the range chart or not, and then same as vertical and horizontal lines if you want to clean that up. And then ultimately show the notes. So this is a note pop-up saying that, hey, there's a note here. We can choose to show those or not. We can search by product code and filter this table by product code. We can filter the chart by shift, and we can filter that chart by all of the different work orders that have entries populated against them. If we do have the table showing, what we get is this nice little bar that we can drag, and it's going to take us back in time so that we can see. So this entry right here is going to correlate with the data point just underneath it, and so on and so forth. So we can see all these different colors in the table. So when they're showing up as yellow, that's showing that when that sample was taken, we can see the hover over it was less than the X-bar LCL. So it went under the lower control limit for this time period that that control limit was specified. We can scroll up and down and see all of the individual measurement counts for a sample. And then what we get at the bottom is we get a sum of those measurements. We get the X bar value. And these are also evaluated based off of whether they were in control or in spec. And then, of course, we get the range as well. We get nice little highlighting points. So this one was out of control, at least the not the individual items, but the overall X bar actually was flagged for out of control. And then if we scroll over here, we get these, which were flagged as out of spec for the X bar value. We can also go to a histogram, get a very nice, clean histogram chart. We can see control limits on here, and then we can see the population in the fields that they are. Very similar in chart options, so we can choose our tick labels or not. And of course, grid lines and the vertical chart, so we can swap it to being a horizontal chart if we wanted to. We can also filter by product code, shift, and work order, as well as the same time range. We go to our process capability chart. Very similar to a histogram, except now we get a bell curve and we see spec limits. So we can see our target 4.5, our upper spec limit's 8, and our lower spec limit is 1. And we can see how our entry points are being entered against where we should be. Definitely, I would say that this process isn't very in control. We have some pretty far outliers. This is all just random test data. So what we get on the process capabilities, we get this extra table where for this time range, we can see the mean value, standard deviation value, the CP, CPU, CPL, and CPK values. We have a box and whisker. For this test, it doesn't necessarily make sense because we're not separating it by, say, cavitation like in a mold. So the last item here is piece data. So basically what we're going to get is a row of data for every sample that was ever entered. August 23rd, that was our most recent test. We can see we have 5 weight values. We get our upper, lower, target, our shift, work order, product code, and the user who actually entered it. And then we can simply export this data into an Excel or any kind of other program that you want for future and additional analysis. Let me circle back to that box and whisker. I have a quality lab, and in quality, I have this test set up, which is basically, this is a mold, and maybe our mold is quadruple 0 for part number 1, 2, 3, 4, 5, 6. This mold is a 4-cavity mold, and we want to check dimension A on this 4-cavity mold. So we can see our summary. We have 5 samples for this. The control chart, we can select each individual cavity within that mold and see how that's running. Same thing, we get a histogram, we get capability, and then for box and whisker, this is where the box and whisker really comes into play. Since we're measuring dimension A, it's the same dimension for all cavities, except we want to analyze the variation between cavity. We can see that cavity 3 and cavity 4 are operating pretty similar to one another. Cavity 1 definitely has the most variation. We can see some outliers at 17 and 10, and then even that subset between 15 and 12 is much different than a 15 and 14. These are much more consistent than a cavity 1 here. We do get additional chart options, so if you don't want your boxes filled, you want a very simple chart, we can do that. We can take away the legend, and we can show tooltips if we wanted to. If there were more than one dimension being calculated, or if there were more than one dimension that we were taking sample data from, we would actually filter by here. So if there was a dimension B, we could ultimately swap to a dimension B here. That about wraps it up for the analytics we have. Ultimately, as far as sample data entry goes, we can do via a keyboard sample entry. We can do, we can integrate, automatic caliper entry in. And we can ultimately do data import via CSV or TXT files, as well as SPC scheduling. So we have some very robust scheduling tools available that we can probably show you in a version 2 if there's any interest in that. I think that's about it, Dave.
Thank you, John, for proving my earlier point of you being the foremost expert of SPC, certainly on this team, if not the world, on the Ignition platform. And now John's blushing a little bit as he normally does.
Only a little bit, Dave.
Only a little bit, John. But no, thank you for that, John. I think it all makes a lot of sense, and this is something that we could roll out in a facility in some number of weeks to get virtually any facility up and running with SPC, with the idea of getting you guys up and running quickly so you can start collecting data as we continue to figure out exactly what you're looking for and build from that point.
See, I told you it was really good with this. Again, this is just some of the basics that we've put together. John has built out 3 or 4 or 5 times as much of this on Ignition, and we'd be happy to talk to you about what SPC could look like for your implementation. Please remember to like, comment, and subscribe. Ask any questions that you have and reach out to see what you think about SPC. Again, Dave from Corso, drinking my coffee. Talk to you guys soon. Bye-bye.